It is March 18th. Again, this is our third problem. Charlotte did the first one. We all did the second one together when we were getting rid of a nasty fraction and solving for x. And now we got Jake riding his bike. Jake rode his bike m miles in 2 hours on Sunday of this past week, or this current week, I should say. On Monday, he rode 3 times as far in 5 hours. Jake averaged over the 2 days 12 miles per hour in his bike ride, or on his bike rides. How far did he ride on day 2? Show all steps. Good luck. All right, Betty, ladies and gentlemen, we're back. So we've gone through a lot of answers that were wrong from the class, and then I have ultimately said that the answer to this problem before doing any work is 21.82 miles, since the question is, how far did he ride on day 2? Now, before we even start plugging numbers in, what do we know? What do we know before we start plugging numbers in? What is something that the problem tells us that we have to be able to use in order to solve for day number 2 totals? I mean,
we have to use the average 12 miles.
he averaged 12 miles over the 2 days. 12 miles per hour, right?
Yeah.
Not 12 miles, but 12 miles per hour over the 2 days. So how do we get? So we know that we somehow need to arrive at 12 miles per hour over the 2 days. How did we get there? Niall?
Okay, so everyone,
Just the formula. No. I just want the formula for how we got to 12 miles per hour.
oh, so we have m over 2 plus.
Okay, even before that. In order to get to an average of 12 miles per hour over the 2 days,
Yeah.
how did we do that?
Um.
I don't know that. I'm probably not asking the right question, so I'm just going to put this up here. Day 1 total, right?
Yeah.
Plus day 2 total. And Niall, you're on the right track, but this is, I'm looking for something a little bit more broad. Is that equal to 12 miles per hour? What do we got to do to get to 12 miles per hour, Marissa? Divide by 2, because it's an average, right? 12 miles per hour is his average. So we got to take the day 1 total plus the day 2 total and divide by 2. So now, Niall, to you, what is his day 1 total? What do we know his day 1 total is?
It's m miles over 2.
M over 2. So his day 1 total, which is now, we're just simply plugging in for day 1 total, it is m miles divided by 2. Because it says up in our problem, Jake rode his bike m miles in 2 hours. So if he rode 10 miles in 2 hours, it's 10 divided by 2, right? What is his day 2 total?
3m over 5.
3 times as many miles as day 1. Over how many hours?
5.
5. That's his day 2 total. Okay?
When you divide that all by 2.
This whole thing needs to be divided by 2 because we're still looking for an average, right? You guys with me?
Yep.
And it's set equal to what now?
12 miles an hour.
12. I'm just going to say 12 for now. We know it's miles per hour.
Yeah.
Now, solvable?
Yeah.
And you guys know that speed is distance divided by time, right? And this is our distance divided by our time.
Okay, so.
And it's an average. And there's 2 full days, 2 total days. Okay, hold on a second. I'm going to pause it for a moment. I think. All right, so we're back. What are we going to do to solve for the variable m? Niall, since you are our expert on this problem, what are we going to do to get m by itself?
Well, first we're going to multiply the what we're dividing m and we're going to multiply by 2.
We're going to get rid of the fractions, right?
Yeah.
And we just happen to have a couple of different fractions going on here. In our fraction, in our overall fraction, m over 2 plus 3m divided by 5 over 2, we have to get rid of the big, huge fraction. So we're going to multiply what you said by 2. And if we do it to the left side of the equation, we've got to do it to the right side of the equation.
So
Okay?
now you have
Clean it up.
m over 2 plus 3m over 5 equals 240.
m over 2
I mean,
plus
24.
3m over 5 is equal to 24. This already looks a little bit better, doesn't it?
Yeah.
But it doesn't look good enough because we don't want fractions, as we talked about in our last problem. So Niall, what's next?
So now we found the least common multiple. We multiplied them both by 10.
So he said find the least common multiple of our denominators. So the least common multiple of 2 and 5 is
10.
10. So you're going to multiply this by 10, and you're going to multiply
That by 10.
this by 10. Clean it up, Niall.
And so now we have 5m plus 6m.
5m plus 60m divided by 5. Is it 6m?
6m, yeah.
6m, okay. 30m divided by 5, sorry.
40.
equals 240. Does this look better, guys?
Mhm.
Okay, so we've got to 5m plus 6m equals 240. Keep going now.
So now we combine like terms.
Yep.
11m equals 240.
Combine like terms, we got 11m equals 240. Keep going.
And then we just divide them both by 11, then you have a 21.81 repeated, but you can just round that to 21.
Did we say 21.81?
82.
Are you sure it's 21.82 or 81?
It's 21.81 repeated.
What's 240 divided by 11?
21.8181.
21.8181.
Yeah.
So rounded to the nearest hundredth would be 21.82.
2.
Like I said, right? So m equals 21.82 miles per hour. The question, though, is not what m is. The question is how far did he ride on day number 2, right? Is that the question?
Yeah.
By the way, what is m? M would be miles, right?
He rode his bike up.
Okay.
Yeah.
So how far did he ride his bike on day 2 total? And day 2 would be 3m divided by 5, right? Or not. What is the answer? 21.82 miles. Now?
He rode 130 and 92 hundredths miles on day 2.
Okay, let's pause this for a second. Moralny, what's our answer?
65 and 46.
How'd you get that?
Well, once he found M, you have to multiply it by 3.
So we know that he rode 21.82 miles per,
Hour.
was it per hour? Or is it 21.82 miles? Miles for every hour, right? Is it for every hour? Because he averaged 12 miles per hour. So what's the m equal? Miles. It's just straight miles. And we're going to multiply it by how many ever hours he rode on day 2, right? How many hours did he ride on day 2?
5.
He rode 5 hours on day 2?
Yep.
Didn't he ride 3 times as far on day 2? Okay, he rode for 5 hours, but do we want to go by hours, or we want to go that he rode 3 times as far on day 2 as he did on day 1? Isn't 21.82 how many miles he rode on day 1?
Yep. Yeah.
So if he rode 21.82 miles on day 1, how many miles did he ride on day number 2? You have to multiply by 3, not 5, right? Didn't you say 5? So you multiply it by 3, and you get 65. What is the answer? 65? 65.46 miles on day number 2. So our ultimate answer would be 65.46 miles on day 2. Studi?
So where it says 21.82, shouldn't the label be miles instead of?
Yes, it should not be miles per hour. You are right. That's what was messing me up too there. So it should be miles because we had to use miles per hour to get to how many miles he was riding on day 1 because that was the only thing we knew. Yeah, that was my fault. Ultimately, he rode 65.46 miles on day 2. To me, the tricky part, as you can see by our confusion at the end there, was answering the question. And what did M really represent? So going back in the problem, we realized that M represents how many miles he rode on day number... Everybody, M represents how many miles he rode on day number 1. And that's really what we were solving for, so that we could answer the ultimate question. Points, do you want to grade it real quick? Yes, I do. I do not count this as part of what you need to do, although you did need to know that that was ultimately what you were basing it off. Your ultimate equation would be the first point. Second point would be multiplying both sides by 2. Woo. Third point would be cleaning it up. Fourth point would be getting rid of the fractions. Fifth point would be the cleanup. Sixth point would be combining like terms. Seventh point would be continuing to get the variable by itself. 8th point would be solving for M. And then the 9th point would be ultimately plugging in the number to M to get what his day 2 total was. Okay? 9 pointers. Questions, comments?